Colleagues, welcome back to the office. It's Steve, and welcome to our podcast for today. Today, we are going to be diving into a new series for CPE today, which is Database Basics for Financial Professionals. This is a topic that I have really wanted to address and dive into really from the beginning of starting this series. We're about 80 episodes in now, which is incredible. And this is something I've really wanted to cover really since episode 1. And I feel that databases are one of these things that is used everywhere, absolutely ubiquitous, but unfortunately not very well understood by most financial professionals out there. Most financial professionals are very familiar and comfortable with things like Microsoft Excel or running reports in Quickbooks or other things and solutions like that. But when it comes to, for example, working with a database, they kind of shy away from, which is really unfortunate because databases are really kind of no more difficult than what you would see with a standard spreadsheet. They're more formal, they've got more rules, but the way the data is stored and recalled is virtually the same. And I'm going to explain and go through some examples today to kind of show you that. But this is a series that hopefully, if you're watching, you're a CPA, you're a bookkeeper, you understand that the information that you're working with is being stored in a database and you want to be more familiar with how you can access it and work with it on your own. To use this knowledge, for example, to write your own reports, to put together dashboards in Power BI and other solutions, maybe to do your own integration projects and other things like that. With a solid understanding of how database principles come together and the basics of how they work, you're going to be able to address and learn and work with these solutions on your own. So in this series, we're going to do at least 3 episodes in here. We'll probably end up doing more because I really don't see this as being a topic that's going to end anytime soon. My intention is from start to finish to give you, the financial professional, the knowledge necessary to really kind of make databases work for you, to give you the tools, techniques, and the insight to pick a database solution, write queries, extract data from that, and then ultimately use that information to produce reports for your organizations. In our first episode today, we're really just going to do an introduction to databases. I really want you to have a general understanding of what they are, how they function, how they're different than a spreadsheet, and really hopefully to demystify some of the specifics around how a database operates, hopefully make them a little less scary. In our second episode, we're going to dive into setting up a database. We're going to work with some basic queries. For our purposes, we're going to use relational databases, and I'll talk a little bit more about what a relational database here is shortly. But we're going to work on examples that are going to be reflective of the work that you are probably doing on a day-to-day basis, pulling order information, pulling customer information, and more. In our third episode and beyond, we're going to start to look at some of the tools that make working with databases effective and easy. And then beyond that, how you can turn this data into actionable insight using tools such as Power BI and more. It's Database Month here at CPE today, so hopefully you will be armed with this knowledge and will be able to make good, effective decisions about how you use databases going forward in your career. Now, we're going to get started here just in a minute, but if you are a financial professional, I want to remind you, you can earn credits for watching or listening to today's podcast. It's super simple. After watching or listening, head on over to cpetoday.com and use course code DBB1. Again, that is Delta Bravo Bravo 1 to find today's course. You'll take a short 5-question quiz, and upon passing that quiz, you will earn a credit for today's class. And with your purchase, you'll get copies of the learning materials, you can ask questions, and more. But if you are an active learner and maybe you are watching or listening to this on your commute to work, it's super simple. After getting to the office, just take the quiz and you will get your credits. If you're a first-time listener to the podcast, thank you so much for coming. It is an honor and privilege to bring this information to you. How about you get a free credit on us? Use coupon code ONEFREEPODCAST at checkout, and you can choose the podcast of your liking, whether it be this podcast or something else. You can get a free CPE credit just for trying out the solution. And hopefully you'll find some other courses and content that you find interesting as well. Now, we're going to get started here, but before we do, I really want to just take a second and I want to address a question that you might have, or at least I had right at the beginning when I was first learning about databases. Why is this relevant? And why does it matter to me? Well, there's a lot of different ways that we can answer why databases are relevant to your professional experience. And frankly, in my opinion, in today's world in 2022, this knowledge really isn't optional. That everything in the world that we're working with, every system, every technical layer, every platform, in some respect is using a database. And knowing how to operate and work with the database is knowledge that you will reach for time and time again. As a financial professional myself, if you're a new listener to the CPE Today podcast, I'm a CPA. I grew up working in an accounting practice, but have since turned my efforts to software development over the years, but still work very actively in financial accounting. The knowledge that I have about databases isn't something I use occasionally. It's knowledge I use every single day. I personally feel that the knowledge that is probably coveted the most by myself and other people is just the fact that I'm really technical, that I can work with the database. And a lot of it isn't that hard. And this is knowledge that you can acquire and you can start working with in hours. I mean, we're not talking about something you need to go back to school and get a master's degree on. My hope is by the end of this podcast, you will have actionable intelligence that you can actually physically work with the database on your own. So who did I write this for? Really, I wrote it for the person who wants to write their own reports. You're working with an accounting system. You want to be able to extract data from there directly into Excel using tools like Power Query and be able to write your own pivot tables using Power Pivot and more. Well, you know what? Yes, that's an Excel tool, but that data coming from a database is going to require you to have some knowledge about how databases operate. Maybe this is for the person who wants to do integration between the different systems and applications in their business. Maybe you're working with a customer relationship management system, a CRM, and you're working with an accounting system, and you want data to be able to move back and forth between those systems. Well, guess what? You're going to need to have knowledge of how a database operates. Maybe you're looking to do some more advanced business intelligence. You want to do dashboarding using tools like Power BI, Tableau, and other solutions like that. Well, as beautiful as those dashboards are, that's really the last mile of producing them. The styling, the color, the bar charts, whatever. I mean, you need to know how the database works in order to be able to produce that chart and graph. Okay, so that underlying knowledge is the part that I feel that almost everybody is lacking. Maybe you've mastered Excel and you want to go on to the next level, and Excel is great. It's a spreadsheet application. If we go up the chain of command, let's call it that, databases are that natural next progression on your way of being more technical. And from there, you'll probably go into programming. But the knowledge that's required for accounting and databases are super complementary to each other. And you'll find that once you kind of get the principles down, it's really not scary any longer. It's not hard to work with. Maybe you want to start working with some web technologies. Maybe, you've got a SaaS, software as a service application. It's got a REST API. Maybe you want to start pushing and pulling data to and from that solution. Well, guess what? Databases are a natural knowledge source that you're going to need to be able to work with that technology. So, frankly, I built this for the person who wants to extend their knowledge, for somebody who wants to start doing more complicated reporting, working with databases. And this is for you. This is that knowledge that I think you're going to need in order to be able to work with these solutions effectively. You're not going to end up being a database administrator. You're not going to know everything possibly under the sun. But my outcome from this is to give you enough knowledge to write reports, to do basic integration, to produce charts and graphs and business intelligence tools, to do everything inside of Power Query and more. Well, you're going to get that from your knowledge today and over the series of the next couple of events and podcasts that we have coming out. All right, so let's go ahead and talk about and start our discussion with what is a database, okay? Well, with respect to a database is a collection of organized information inside of a computer system. That collected information can be really anything. Most often it's text information. It could be customer information, the address, the phone number, the customer name. It could be product details, invoice details. It can also be other stuff too, images, music, and more. Databases in general allow for a methodology of storing and recalling information. They prioritize a couple of things. The ability to be fast, the ability to be really efficient, in terms of how they store data. So you're not storing anything any more than what you have to. So it's not any larger than it needs to be to store that and contain the information you're looking to have. They prioritize security. So if you need to store information and then segment it so that certain users can only do certain things, well, a database is really good for that. They're very effective for all different types of use cases, and pretty much everything today in some capacity is using a database. From your email to the pictures on your phone and more, you can use it for virtually everything. Databases are also very effective for applications. We can use just raw databases to store anything, but pretty much every application you're running is using a database on the back end. It might be visible to you, it might not be. A good example of this would be Quickbooks. Quickbooks is 100% a database-driven accounting solution. However, most users will never directly interact with that database. It exists behind the scenes, but it's there. It's sitting there right at the ready for you if you know how to work with it. But you interact with the user interface. The user interface is what's interacting with that raw data. Databases are also super effective for multiple users. Spreadsheets aren't. For lots of different reasons, which we'll address here in a little bit. If you need to start sharing data with multiple people under multiple different conditions, multiple different types of devices, desktop, mobile, and more, databases are the best option for that. And databases just store data. They don't store formatting really. They don't store, logic per se. They can store some of that, but not directly. Usually we're using other intermediary solutions in addition to the database. But we store the data in that central repository. Think of it as kind of like being a safe for information. And then we recall that information through queries to be put into something like a report, extracted into a database, presented on a website, or in your favorite applications. Okay, so that in general is what a database is. It's a methodology for storing information. And we use several different types of databases. Some are specific to certain use cases. Some are designed for large scalability. Some are designed for certain types of media and more. But the methodology of putting data into one central place, that's the principle behind a database. So here's some important things that you need to know about how databases operate. Okay, again, fundamental component of all storage in virtually all systems. Doesn't matter if it's cloud-based, doesn't matter if it's on your computer using something like Microsoft Access or QuickBooks, it's storage. That's really what we're talking about here is storage. Everything from data from your accounting system to the photos on your camera. They can be used virtually everywhere, in virtually all systems. Knowing how to put data into a database and then recall information from that database, in my opinion, is essential information for today's financial professional. If you can work with the database, being able to store stuff and then write the necessary SQL, structured query language, to get that data out of the database, you are going to be flying high. It's going to open up a ton of different opportunities for you above and beyond just financial reporting. And in my opinion, this is just another of a long example of things that should be taught in college, because this is useful whether you're a marketer, whether you're a business analyst, an accountant, or more. In my opinion, this is just something you just need to know now. All different types of databases, all different types of use cases, all different types of deployments. As a software developer and a financial professional, somebody who actually builds databases 100% from scratch, often I'm trying to figure out what the use case is, what this database is going to be used for, how it's going to function. And then I pick the right technique. I pick the right solution. I pick the right platform. I pick the right deployment. Sometimes you do stuff locally on your computer. Sometimes you do it in the cloud. More often than not, it's in the cloud now. Sometimes you're doing it using a relational database, a structured database. Sometimes you're using a non-structured database. But the nice thing is, just like one of my favorite tools here from my good friend James, the Swiss Army knife, we have lots of different tools and we pick the right tool for the job depending on what we're trying to do. Having good working knowledge of how database is stored will pretty much improve every aspect of your professional life. As I mentioned, this is the knowledge I feel is coveted the most. The fact that I can pretty much work with any type of database and I can pull data in or out. When you know how to work with the database, it's kind of like knowing a foreign language. Let's just take something like knowing Spanish as an example. If you know Spanish, there might be regional dialects, like the language is going to be a little bit different from Mexico or Guatemala to, for example, Spain for that matter. But you get a pretty good sense of how it works. You have a good sense of the syntax of the language. Vocabulary might be a little bit different. How you structure sentences might be a little bit different, but you have a pretty good idea of how it's done. And knowledge of database is very similar. For myself, I'm most familiar with and use most often standard MySQL, MySQL, and MariaDB SQL. But with that knowledge, I could still work with Oracle. I could still work with Microsoft. I could still work with Access and other solutions like that because I understand the language. I can speak it. So think less about the specific flavors of databases you want to learn and think more of absorbing the principles of how a database operates. And with that knowledge, you'll be able to apply it to all different types of products and projects that you might be working on. Also, this isn't too difficult. In my opinion, you should be able to pick up the basics of a database in about a week, and you can really master all the major stuff that I think you're going to need to learn in about a month of time. And this isn't necessarily full time. I'm not telling you need to spend 40 hours. Just start working with the database, and you'll start picking it up pretty quickly. And the principles are pretty standard, especially as you start to look at SQL, the language, structured query language. You'll notice that it's pretty simple. It's using basic vocabulary, and there's a specific order of how you need to ask a question. But if you ask the right question, you'll get a good response, and you get the information that you're looking for. And I have found in my professional life that takes about a week or so to really kind of get comfortable and to think logically in your head of how you would form the question to get the data you're looking for out. The mastery of this can take a lifetime. I can tell you could probably master most of the basics in about a month or so, but you'll spend a lifetime learning the ins and outs and best practices, and you'll learn a ton along the way. But this isn't something, again, that you need to go get a graduate degree for. I think most folks can pick this up in about a week or so. Now, when do you want to use a database? Well, databases are awesome. And once you kind of know the principles of it, you find yourself using them pretty much for everything. You could store simple records. You can create complicated data sets, just depending on what the specific needs of the project you're working on. And for most of you, you'll probably end up using a database through some sort of application or project or solution that you're looking to do. I don't expect you, nor am I designing this course to really kind of give you the knowledge to make a database from scratch, although that's not really difficult to do. It's just very similar to building a worksheet or a workbook. But, as you start to acquire this knowledge, you'll find you actually use it quite often. Databases shine in a number of different ways. They're great for storing large quantity of diverse data. Databases can range from a couple of simple tables to hundreds or even thousands of tables as needed. Databases are fantastic for multi-user access. So if you need lots of people being able to interact with the same data at the same time, you're going to have to use a database. A good example of this would be something like an e-commerce site. Can you imagine everybody having their own isolated version of a database and then trying to sync all of those different orders together? Of course not. We put that database into a central location with the right users' roles and permissions, and then everybody interacts with it. And the database is responsible for syncing changes in orders and making sure there's not conflicts and people aren't ordering things that are out of stock because the last person ordered it, and more. So when it comes to multi-user access, this really shines, and there are lots of different tools and cloud services that are out there now, like Office 365, which is one of my absolute favorite solutions, is great because you can have multi-user workbook access. But that logic starts to break down as we talk about larger numbers of concurrent users, hundreds or even thousands. Databases are going to be what you have to use. Databases are great when you have mixed use cases on how you want to store, retrieve, and report data. You might have people interacting with the front end website. You might have your back end administrative users using a custom application. And you yourself might be using Power Query and extracting that data and reporting upon it. Well, databases are great because they're really kind of agnostic on the application and the process of pulling that data out. At the end of the day, it's all SQL, structured query language, to the database. Likewise, if you're accessing using a variety of different mixes, sometimes you might use the application, sometimes you might use the website, sometimes you might just use something else. They're also great when you have security requirements. Although you can set up a database a number of different directions, almost always you'll have this concept of users inside of a database. And once you have users, you can have roles, you can have permissions associated with that. And the nice thing about that is with permissions, you can now provision a database so that only certain things can be done by certain people that have those correct permissions associated. You could do some of this with respect to a spreadsheet. But with a spreadsheet, using Microsoft Excel as an example here, it's really all or nothing. You can either password protect the workbook or not, but that password's the same for all users. With a database, I could password protect individual databases or tables inside those databases, or even individual items inside of those tables, and restrict them only to the people who are supposed to have access to that at any given time. I think that's one of the things that really make databases shine, is that security and permissions. Now, let's go ahead and compare a database to an Excel workbook. Again, most of you are financial professionals, so Excel is probably, something that you live and breathe on a day-to-day basis. Good news is your knowledge of Excel is not going to go anywhere. If anything, it'll just be improved and will become more useful the more and more you learn about databases. I can tell you from my perspective, I became more effective with working with the database. I became more effective in Excel as I gained more database knowledge. I started knowing and being able to do more and more with Excel once I had really good knowledge of how databases are operated, because you find that it's a way of thinking. And once you have this way of thinking, it just kind of spills into other aspects of your life. You start organizing things better and more effectively. So let's do a comparison between the Excel workbook and the SQL database. Okay, so what is an Excel workbook? Well, a workbook is ultimately a collection of worksheets. You have one XLSX file, a standard Excel file, and that XLS file will have several different worksheets inside of it. Well, a SQL database is a collection of tables. So inside of a database, it's not just one big monolithic thing. There's lots of different types of things inside of a database. You can have tables, which are collections of raw information. You can have views. You can have functions. You can have stored procedures. These are programmatic things that you can do upon the data. But ultimately, it's just a collection of data in the same way that a workbook is just a collection of worksheets. Okay? Now, think about a worksheet. Well, what is a worksheet? Well, a worksheet is a collection of rows and columns. So if we had our Excel workbook, we're going to have column A, row 1, column B, row 2, so on and so forth. There's some structure to it where it is almost like a grid, but ultimately it's just as many columns as needed and as many rows as needed. Now, there's an important thing that you should know, and this is true for both Excel as well as SQL. However, with Excel, it's not enforced, but with SQL it is that rows represent records and columns describe those records. Meaning a row is supposed to represent a specific order, a specific product, and the columns describe the information about those rows. So column A could be product ID, the name of the product, the price of the product, and other information related to it. But that paradigm of columns describe rows, that's rock solid. And that's how you should be designing your workbooks no matter what. Now, on the SQL side of this, tables inside of a database are exactly the same thing as a worksheet. They're a collection of rows and columns. The difference is there's more structure to them, and they're defined in the data that they can hold. More on that here in a moment. But a worksheet just stores information in a grid format. A table stores information in a grid format. Rows represent each individual record inside of that worksheet, and the columns describe what is contained inside of those rows. Now, there's some general best practices and principles you should follow. As an example, columns should be single purpose. As an example, let's say you're working with your product information. Well, something like the product name should only ever hold the product name. Something that holds price should only ever hold price. You never mix and match stuff. If you need to store more information about things, instead of, trying to make a column solve multiple needs by, maybe comma separating a value inside of a specific cell, you create another column. Always, always, always. And that's true for both Excel workbooks as well as databases. So columns describe rows, rows represent records, but otherwise worksheets, tables, exactly the same. What? Well, let's go down this a little bit further. What are rows and columns? Well, rows and columns are ultimately a collection of cells, and that's exactly the same over here. Tables are a collection of rows and columns, which are ultimately collections of cells. And what are cells? Cells contain data. It can contain a single thing like a product price, a name, an email address, a phone number, or whatever else. But that one cell contains one bit of data. And as long as you follow that principle, try to store things in their smallest divisible unit inside of a cell, there's virtually no difference between how an Excel workbook works and how a database works. Okay, I'm traditionally talking about SQL databases here. There are some differences with non-relational databases, which we'll talk about a little bit later on. But in your standard SQL database, just think of it as a more advanced Excel workbook. Think of it as an Excel workbook with some more defined rules associated with it. Now, let's look at some of the other differences between an Excel workbook and a SQL database. Well, in an Excel workbook, the user is directly creating, working with, and managing the workbook itself. And inside of Microsoft Excel, they're adding worksheets, they're adding columns, they're moving things around. They're directly creating how that data should be stored. Okay, but it's very much user defined. And you can end up with some very funky spreadsheets. I'm guessing most of you have probably come across some of these at some point in your career where you're like, who the heck created this workbook? Well, it's probably somebody who didn't have really good knowledge of how data should be structured, because there's no right or wrong way, but let me tell you, there are best practices that you should follow, okay? Because Excel is very loosey-goosey, you can end up with very well-defined workbook, but more often than not, you end up with normal or mediocre workbooks that aren't as efficient as they could possibly be. Now, databases, on the other hand, are typically set up in advance. They're set up by somebody who will have knowledge of how databases operate. They will have a specific form and function. So again, databases have rules. So they have more advanced characteristics and functionality associated with them. And they also have some pretty firm guidance in how they should be structured. For example, a table, and a table is just the equivalent of a worksheet, but in a database, should be single purpose. A table for customers only ever contains information about customers, or a table about products only contains information about products. In a worksheet inside of Excel, you could get somebody who could mix and match and move that stuff around, but in a database, you'd never do that. It's going to typically be set up by someone in advance. They're going to know what they're doing in the context of what type of data they're storing, and that data will have a specific form and function. Additionally, another good example inside of a database that makes it separate from Excel, when you're defining the schema of that database, you're defining it by columns. So you're going to create a column, for example, to hold certain types of information. So, for example, first name, last name, email address, so on and so forth. Well, that column is only going to hold that specific information. And we'll also define what type of information that column will hold. Text data, it could be decimal data, it could be integer data, and it will only accept the data that matches that specific type. Okay, so a little bit more formal, and that's a big distinguishing difference. Excel workbooks, less formal. Databases, on the other hand, more formal. Excel, admittedly, easier to work with. It's where we all start. It's where we all cut our teeth. Databases, on the other hand, are going to require some specific and specialized knowledge to get up and running. But again, hopefully by the end of this class, you will have that knowledge to write your own. Excel, when we want to modify things, we do this through formulas. Formulas typically apply to a discrete selection of data, meaning we can apply it to rows 1 through 5, skip row 6, go to 7 to 10, so on and so forth. In a SQL database, however, formulas apply to all data within the scope of the query. So we don't have the ability, for example, or I should say not easily have the ability to exempt certain columns or certain rows. When we modify data inside of a database, almost always we're modifying everything in that specific column. If you're familiar with Power BI, if you're familiar with Power Pivot, when you're using things like measures, it's exactly the same as that, where you write a formula for a measure, it applies to everything in the scope of that measure. With Excel, you could format to the cows come home. You can make it look any way you want. With a traditional SQL database, it's no formatting. It's 100% text. And personally, I find that kind of liberating because it's nice not having to think about how it is going to be styled. The formatting, for example, will typically come through the report you write, which is a separate component of it. But the raw data itself, it's unformatted. It's just standard text. Excel workbooks, at least traditionally, difficulty with sharing, difficulty with security, difficulty with continuous updates. These have been alleviated to a certain extent with services like Microsoft 365, but they are still issues nonetheless, especially as we start to look at large scale. Databases, on the other hand, super easy to share. Security is a breeze, and continuous updates are part of the design. So with a database, if you've got to share this with multiple applications, multiple different people, you're going to have a lot simpler work with the database versus with that Excel workbook. You're going to always be behind the eight ball, if you will. Excel workbooks have really specific functionality like pivot tables and charts and graphs. You can do all that kind of stuff right inside that file. Databases, at least in the traditional sense of a database, that's not there. Databases solely store data. The analysis, the reporting, the view, doing things like pivot tables, charts, those are all going to come from the tools you choose to use. It could be Excel, it could be other solutions like Power BI or MyDBR, but the database is not generating that information. It's you. All right, folks, let's go ahead and have our first review question for our class. When should you consider using a database for your project? Okay. Should you use a database when you need to store large quantities of diverse data? Absolutely. Multiple people or systems need simultaneous access to that data. Absolutely. You have complex security requirements and you need specific permissions. Absolutely. Correct answer here is all of the above. That is what separates, and these are some major compelling reasons on why you might want to consider using a database. Now, to kind of go a little bit further into where databases really shine, you got to understand ACID. Okay, ACID is a acronym for animosity, consistency, isolation, and durability. And these all really kind of come back to talk about reliability. When we design a database, we design it to be reliable. We designed it to be durable. We designed it as something that's going to be used period in and period out. So the first one here really kind of deals with the concept of all or nothing. When we work with the database and we're putting data in or getting data out, what we really want to make sure is that it's really fault tolerant, so that if part of it fails, the whole thing fails, rather than we end up in a limbo situation where half of it updated and half of it didn't. So with, and I'm always I find this word so difficult to pronounce, atomicity. With this, really what we're trying to do is ensure that the database is stable and reliable. This isn't something you have to think about. What's nice about this, it's just built into the design of the database itself. With data in a database, we want it to be consistent. We want to ensure that any transaction will bring the database into a valid state, that you don't end into a situation where somebody put some data into it and corrupted the actual database itself. I'm sure most of you at some point in time have worked tediously on a spreadsheet, maybe shared it with your colleagues, and then somehow something got corrupted and now the file itself won't open. Well, if that hasn't happened to you, I applaud you, but for the rest of us, it probably happened more than once. Databases don't have that issue, or at least they shouldn't. It's designed for really high durability and reliability. Databases are designed for isolation, meaning that you can have simultaneous users being able to communicate, update, report, create, read data that will not interfere with other users. It processes transactions simultaneously, but each of these transactions are relatively isolated from each other, so you can have multiple people working simultaneously. And databases are also really durable, so that once a transaction's committed, it will be there. Even if power goes out, if the database crashes, there's errors. When something is committed to a database, it's there until it is otherwise changed. But these make databases far more reliable than, a pad of paper on your office or a workbook for that matter. And you can even improve this with things like logging, security, redundancy backup, and more. Now, what does your standard database look like? And this is an example of what that possibly could. And this is just your standard relational database structure. And we'll talk more about relational and non-relational after this. But I just want to give you a sense of what you can expect it to look like when you work with the database. And it should look like everything else that you work with inside of a spreadsheet. They're not scary. They're not hard. It's just a collection of information. And so in our example here, we have some customers. We have some orders. Now, this is where understanding how database best practices come to fruition. Ideally, when you're working with databases, you want to have things be responsible for only one thing at once. We sometimes refer to this as the single responsibility principle. But if it's customers, it contains customers. If it's orders, it contains orders. But you'll notice when we're working with information like this, if I wanted to get information from one place to the other, I often have to go to multiple different places to bring that data together. And that's normal. And that's actually a really good thing. The benefit when we separate data into their smallest units is that when we need to update, for example, like a customer name, we update it in one place. And when we update it in that one place, it's reflected wherever that data is ultimately used. So when you work with a database, you're often going to be working with several different tables. You'll have a customer table, a vendor table, an employee table, a check table. A solution like Quickbooks, I think, probably at this point has close to 100, maybe even more tables inside of it, because every single little bit of the application is its own thing. And then we often relate those data to get that data together to produce the information that's usable for us. This is where the term relational databases come together. But the data itself looks fairly normal. In this case, it's just spreadsheet data. We have columns, we have rows, we have cells. Now, in a standard business style database, which is most often a relational database, we have these two tables. And if we want to get information from one to the other, we do lookups, typically using an ID of some sort. So if I want to do, for example, go to my order table here and find out who processed a specific order, I'm not going to see, or who bought something for that matter, I'm not going to see, for example, the first name, the last name, the email address of that customer, but rather just that customer ID. So if I wanted to go look up and say, hey, who processed or who purchased order 4557, I'm going to see customer ID 10042. Okay. Now, knowing that, what I can do is a join. And we'll talk more about this in the next episode, SQL itself. But knowing it was customer 10042, I go to the customer table now and I look up customer 10042 and I'm able to get their first name, their last name, whatever information else about them I would like. But rather than storing the full and complete information on that specific table, we just store a pointer, a record locator. And with that record locator, we can go back and we can find out any other information we might want by going back to wherever that source data might be, in this case, that customer table. But this is the standard way of how all databases operate. Now, speaking of standard databases, there are really kind of two major types. Okay, we have relational databases. This is sometimes referred to as a SQL database. And this is the most common database you'll see in business. In fact, this is all we're going to focus on for the context of this class. It's standard. It's just, again, kind of like a worksheet on steroids with much more rigid rules. It's tables, rows, columns, and cells. It shouldn't be that different. Tangibly, I just want you to know that's the only type of database that's out there. We have non-relational databases, sometimes referred to as a NoSQL database. These are typically highly optimized to specific use cases. They typically contain things like key value pairs. They're often used with unstructured data, but you're not going to really see a non-relational database for use in accounting or finance. It's just not common. I'm not going to say it's impossible. I'm not going to say you'll never see it. But for the purposes of you learning databases today, you could just put this on a shelf and maybe come back to it after you've learned a little bit more. Relational databases run business. They run the world. And again, it's just like a workbook with more rules. And that's all you really need to know about it. I mean, it's just like a big workbook with rules and formality associated with it. Now, The relational piece is the pivot point here that you need to really kind of know, okay? Inside of a table, you're not going to see all that information present. You're going to see a record locator. You're going to see an ID. And that is the crux of where most people kind of get screwed up with understanding databases. They're used to seeing everything inside of a single spreadsheet. In a database, you're not going to get that. You're going to see it spread out across multiple different places, but you're going to need to understand where those keys are located and then how to relate those keys to other tables to bring information together. And so a table will typically represent a single thing, and that table will have what we call a primary key. That primary key represents that record locator. So if it's order, it'd be something like an order ID, or if it's check, it'd be something like a check number. And then we use what are called secondary keys. And with those secondary keys, we can then go and find other information about other records. So on the order table, the order ID would be the primary key. A secondary key could be the customer ID, the product ID, the order item ID. Using those secondary keys, or sometimes referred to as foreign keys, we can then go to the other tables and find out other information to ultimately get all the data we're looking for. So with this knowledge, it actually makes it quite efficient. And once you can kind of get that inside of your head, this will become a lot simpler and easier for you to be able to operate. Now, in terms of relational databases, you got a lot of options. There's no shortage of different products, services, and tools. But I will tell you, it's something you definitely want to get right from the get-go. And there are, I would say, dozens and dozens of different types of SQL databases that are out there, but they kind of fall into let's say 4 major categories. One that you might be familiar with is something called Microsoft Access. This is a personal database. It's part of the Microsoft Office suite of products. It's something that you might even have installed on your computer. It's an example of an application-based database. It's simple for individual use, really starts to break down though when you have lots of simultaneous users. And in fact, this style of databases is fallen out of favor and it's not really used that often. The other 3 that we have listed here, MySQL, MS SQL, and something like Oracle or Postgres, these are traditional database technologies. For myself, 99% of the time, I'm using this one right here, MySQL. And specifically, I use a type of database called MariaDB. It's great all around, works easy. It's free. You don't have to pay anything to ultimately use that database technology. It's got good functionality, great speed. And again, it's really reliable, which is one of the major reasons why I use this. Another example of this would be MS SQL or Microsoft SQL. Great all-around database. It's really common in a lot of business applications, and a lot of businesses still use MS SQL, even though it's something that's not free and that you do have to pay for. But it is a really good all-around database for all different types of business needs. Bigger businesses will typically use a bigger database. Oracle as a good example, or Postgres, which is also a pretty big database as well. These are great for large, diverse data sets that need outstanding performance for thousands or even hundreds of thousands or millions of concurrent users. This is a really good example if you pick the right tool for the job that you're working with. Okay, 99% of the time, your needs are going to be solved by either a MySQL database or a MS SQL database. You can use either. My preference, again, and what we're going to be learning with today is MySQL and specifically MariaDB. It's free, it won't cost you anything. You can make big databases from this. It works. For 99% of use cases, it's more than enough horsepower for what you want. Now, another thing you might want to consider is where your data is going to be stored. So after you've kind of picked your root technology, where do you want to put this data? Well, ultimately, you're going to have to make a decision either to keep it local or put it into the cloud. And something I like seeing in today's world is that cloud is the rule, not the exception. For me, 99% of the stuff I do is in the cloud. I have some local things here, like in my home office, but even then, it's being replicated and backed up to the cloud. I would tell you for most of your business use cases, especially in this weird COVID world we're living in now, put it in the cloud. It'll make it easier to be accessible to multiple places. Backup's a breeze. It can be used for something like your website or even more. But Inside of cloud databases, there's lots of specific tools. Microsoft Azure's platform, for example, has a cloud version of the Microsoft SQL database. Amazon Web Services, AWS, also has cloud versions of their databases, including things like Oracle, if you wanted to go big, or you can even go small with something like SQL, MySQL. And they even have their own proprietary database formats based off of MySQL called Aurora DB. But I would tell you cloud is definitely the way to go. But if you're just learning on your own, you could spin up a local instance, and we'll be looking at how you can do that pretty easily here in our next episode. Now, 99% of the time, you're not working with databases directly, but rather you're using some sort of application to interact with that database, or you're using some sort of reporting tool to sit between you and the data. Typically, you're using some sort of collection of different middleware that is formalized, that knows how to talk with the database, and will be able to pull that data in and out. I'm going to teach you how to work with the database directly using tools that will directly allow you to query the data. Most folks never get to that point, but you're here for a reason, so I'm going to make sure that you get that knowledge, where you actually learn how to write the SQL language on its own, okay? But just realize something like Quickbooks, it's almost impossible to work directly with the with the database. You're always going to be working with it through the application itself. But we're going to learn how to get to that data itself. Now, in my opinion, there are really three things that I think you need to know to make working with the database work well. Okay, there's only really kind of three major topics, and these are the three topics that I think a lot of people kind of get screwed up on when trying to understand how to work with a database. And they are keys, relationships, and normalization. Okay, so we've already kind of addressed two of these three, and then we'll talk about, but we haven't addressed normalization. Now, normalization is the process of changing data from the way a database stores data to the way that you ultimately want to consume this information, how to make it human, and how to make it useful for humans in a friendly format. That process of normalization is the process you're going to have to memorize and put in your head to make use. Okay. Now, for that normalization process to occur, you need to know two things: keys and relationships. Keys are the identifiers for records. They're all around you: invoice number, customer ID, booking number, so on and so forth. And how those keys relate to other aspects of that database are going to be through relationships, or when you're writing SQL, we call them joins. So understanding how data is structured and how to join them up, it's kind of like a big jigsaw puzzle. That's the process of normalization. But as we start to look through this, I want you to think about and remember, what are the keys of the database table I'm working with currently? How does this key tie this specific object back to something else? So how does it tie this back to from the order table to the customer table? That's going to be through the relationship. And if you can master those, that normalization process of taking data from the fragmented way databases store information to a usable human-ready version, you'll be rocking and rolling. It'll be simple and easy for you to work with. Again, I think you can master this in about a week. Now, with respect to keys, some specific advice for you. Whenever you have the options, this is what I would recommend when you can define the keys yourself. And as you start to work with databases, you'll understand as you start to work repeatedly why certain techniques or best practices are recommended over others. So first and foremost, if you're thinking that, hey, I want to do some integration between different products and services and platforms and apps inside of my company, first off, you need to make sure that you're working with the same terminology and you standardize your keys throughout the system. Typically, we would call this, for example, you would want to have a database of record, the source, a sole system of truth inside the organization, so that, for example, an ID is the same regardless of whatever system you're using. You don't want to, for example, have two systems with two different IDs. Customer ID should be the same in system A as it is in system B. It should be the same ID in your accounting system as it is in your customer relationship management system. So ideally, whenever possible, standardize keys, make them easy to use and simple. Whenever possible, keys are best to be numbers, integers to be specific. Numbers are faster for systems to process. They're easier for us to understand. They're easier to work with. Keys should be consistent. When you're building your databases and working with your data, You want to have something that is rock solid, that's not going to change. Something like a last name, an email address, an address. These will change throughout life potentially. So when we pick like a customer record locator, we want something that's independent of their name, independent of like their communication. We want something like a customer ID. That makes it very easy to be able to identify that person. And if their email address changes, great, not a problem. It's not going to screw up all our historical reporting. Whenever possible, we want to keep our IDs simple and easy. You don't want them long, complicated. Integers work really good. And have one system that kind of controls everything inside your business. Pick a database inside your system. That's the single source of truth. That's the record keeper for your organization. And all other systems will be ancillary to what that system is. It's not the same for every business. It might be your accounting system, might be your sales system, might be your ERP system, but pick a system and then stick with it. All right, here is our next review question. Which of the following is a design recommendation for your database keys? Okay, use complex keys and make them as long as complicated as possible. No way. Okay, use different keys for each of your systems. No way. Try to keep keys consistent, especially in type as well. Try to keep them as integers. Use letters if possible. Numbers are slower for systems. No way. Correct answer here is avoid keys that can change. Don't use email addresses or last names. Now, the way that we're going to work with databases and what you will most likely learn as we go through this is the language of databases. You're not going to be programming. You're not going to be writing, C++ code to build your own database engine. There's no need for that. Nobody needs to know that knowledge. But what you are going to learn is the language. In the same way that you would get on a plane and go to Spain and talk Spanish to the Spaniards or anywhere else in the country, you're going to learn the language. So when you get on the plane to go to database land, you'll know the language of the land, which is SQL. Okay. Now, SQL, it's a special purpose programming language. Pat yourself on the back here. You are going to learn a programming language, and it's designed for data, and it's specifically designed for data held in a relational database system. Now, SQL is a standard language for interacting with databases. It's even an ISO standard. Pretty much every relational database uses roughly the same vocabulary, roughly the same structure, roughly the way you ask questions is going to be the same. There will be some differences and some specific nuances, but for the most part, it's all the same. And the nice thing about this is with this knowledge, you will have access to a vast array of different potential projects and solutions to work with. And this knowledge is not specific to one type of system like QuickBooks, and you know how to do accounting in QuickBooks, but you don't necessarily know how to, process that order in Dynamics. SQL is SQL is SQL, okay? And understanding how data is structured, that is even independent of SQL itself. Understanding how a database works is super helpful. SQL is based on that relational model. Pretty much all data is represented as what we call tuples, ordered list of elements, and they're grouped by common relationships. But we're going to learn the basics of this language. We're going to learn vocabulary such as select, from, where, group by, and more to be able to slice and dice our data and be able to pull information out in whatever format we might need to get exactly the data that we need to ultimately produce better reports, to build better dashboards, to do integration between our systems, and more. All right, let's have our final review question. What does SQL stand for? Is it standard query language? Nope. It's sometimes referred to that, but not quite. Sales qualified lead? No, it is not. Search and query language? Old school way of referring to it, but that's not the correct. The correct answer here is structured query language. Okay, some final thoughts as we head into the second episode. Some things for you to kind of keep in mind. I don't want you to get discouraged. At some point, you're probably going to scratch your head and wonder how the heck all this operates and comes together. It's not that bad. Again, give me a week of your life. I will give you knowledge that you will use for the rest of your life, and you'll find that you use this in almost every project. It's the knowledge that I feel that when people ask me, like, what's the next thing I need to learn as a financial professional? This is always what I tell you. If you don't know how to use a database, this is the next thing you need to learn. Okay. Some parting thoughts. By their very nature, databases are complex. They're pretty unique. The way they hold data is unique. The way they operate is not unique. They're pretty standard in that way. So once you know the basics, you can work with anything. Some things to keep in mind. Databases are structured. They're literal. They're format. You're going to find you're going to need to have good attention to detail. Syntax, grammar, spelling, capitalization, all of that stuff matters when you work with databases. Ask the wrong question, get the wrong response. Okay, but once you kind of understand that it's a literal language, you have to be right. There's not quasi-right. It's right or wrong. You'll be able to identify that in your own work. The order and how we work with the database matters. It's not willy-nilly. It's not ad hoc. When we're working with databases, we're using our forethought. We are thinking about the work that we're going to do, and we're going to do it in that correct order. Databases run from first to last. It's important to know that. So when you write your queries, you get the right data out in the correct order. Also, as you're starting to learn this, don't do this on production databases. Create a copy, do it on your own until you feel comfortable working with your production data. With most databases, there's not an undo button. There's not an undo delete. There's no trash can. If you delete or change something, it's changed there permanently. So as a word of warning, as we start to get up to speed with this, please use what we call a sandbox environment. And with that sandbox environment, you're going to ensure that you're not committing changes that will have unintended consequences on your data. Master this, then move on to your production database, and everybody will appreciate you for doing that. So what did we learn today? Well, today we learned about the basics of a database. We talked about the different types of databases that are out there, the major database functions. We learned about how they operate. We're looking at some specific examples. We also talked about the database strong use cases, their best features, their best functions, things like security, multi-user access, the ability to store large quantities of diverse data, and more. And we also introduced the idea of SQL, structured query language. And with SQL, we will have a common language to be able to push and pull data from our databases. Now, this is just the first of a series of podcasts that we're going to do. In our next one, I really want to get into this. I want to screen share. I want to show you how to set up your first database, how you can write your first queries to get data out. And beyond, I want to talk about the tools that make databases effective and easy. Independent of this specific series of classes, in this month, we're doing courses on Microsoft Power BI, and we're also going to introduce a tool to you called MyDBR, which is one of my favorite reporting tools. Once you understand the basics of SQL, utilizing MyDBR or Power BI will be a cinch. And we're going to talk about some of the different tools that you can use to make working with databases easy. But I don't see this really ending. I mean, there's so much knowledge I'm still learning today. And so there's so many new things that I want to bring to you around this specific topic. Now, if you made it to the end, thank you so much for being here. I just want to remind you a great way to be able to support our channel, our content, so that we can continue to bring new, exciting, and engaging content to you is by getting your CPE credits with us. If you're a CPA, you're an EA, or other type of financial professional that needs credits for continuing education, please consider us as an option for your learning. Today's course code is DBB1. You can go to cpetoday.com and find that course. Take a short 5-question quiz and earn a credit for your learning. And it's a great way of being able to support the channel so we can keep bringing you great content. And if you're a new watcher or listener, you can get this class or any other class of your choosing 100% for free. Use coupon code ONEFREEPODCAST at checkout for the class of your choosing. Now, if you're not a financial professional and you still want to support the channel and support the effort, thank you. Please consider following us on social media. You can find us just about everywhere: YouTube, Instagram, Facebook, and more. And you can also listen to our show on your own schedule on everything from Spotify, Apple Podcasts, or wherever you happen to get content. We'd love for you to leave a review. It really does help new people find the channel and find our content. It is always a pleasure being with you. Thank you so much for your time and attention, and I look forward to seeing you back in the office the next time around. Take care and good luck.